In this lecture, I will talk about the basic strategy to compute limits. The first one is direct substitutions. Many limit computing questions can be solved by using substitution. But before we use this approach, we need to verify whether the function is continuous at the point where the limit is being evaluated. So I use c to represent this point. Then we can substitute c into the function and evaluate the limit. Sometimes we need to verify whether the two-side limit does exist. The second method is factorizations. First, you substitute c into the function. If it ends up with 0 divided by 0, then there probably exists a common factor between the numerator and denominator. Then we can use the factorization method to solve the limit. The third method is limits at infinity. Similarly, substitute c into the function. If the evaluation presents to be 1 divided by 0 or infinity, then the limit approaches infinity as well. The fourth method is trigonometry. I will talk about two special cases of the trigonometry function to solve limits. The first one is sin x divided by x. As x approaches 0, the limit goes to 1. And the other one is cosine x minus 1 divided by x. As x approaches 0, the limit goes to 0. Sometimes you need a definition to solve limit as well. For L'Hopital's rule and squeeze theorem, I'll use a separate lecture to discuss. The first one, substitutions. First, let's take a look at the exercise. Compute the limit of x squared plus 2 as x approaches 2. By using definition continuity, we need to test why is this function continuous? Yes, it is continuous at where x equal to 2. Then we can directly substitute x equal to 2 into the function. And where it comes, the answer is 6. Attention is, sometimes we need to verify whether the result does exist for two-side limit. As example here, we need to evaluate the limit of square root x plus 2 as x approaches minus 2. Apparently, the limit does not exist as left-side limit. And the next method is factorizations. After we substitute a value into the functions, if it leads to 0 divided by 0, we need to use this method. For example, let's take a look at the exercise. Compute the limit of square root x plus 1 minus 2 divided by x minus 3. What happens if you just simply substitute x equals 3 into the functions? And it comes 0 divided by 0. And we determine this form is called an indeterminate form. Similarly, we have other format as 0 divided by 0 or positive infinity divided by infinity. Then this question, there is a common factor exist between numerator and denominator. Let's look at the numerator. The highest power is 1/2, square root of x plus 1. And the highest power in denominator is 1, is a polynomial function. So it's possible we can factor the denominator by using square root x plus 1 minus 2. Then we have the common factor. We can cancel out the common factors and reevaluate the limits. And the answer comes with 1 over 4. Sometimes this method, in this case, it can also be defined as, because you have square root x plus 1, as using rationalizations. Next one is using limit as infinity. First, let's take a look at the exercise. We need to compute the limit of x plus 1 divided by square root x minus 5. As x approaches 5, we need to compute the right side limit. First, we know the top, which is the numerator, is always greater than 6 when we substitute a 5 inside. And the denominator is the value is greater than 5, so you end up with a positive number, but it's very tiny, which is very closing to 0. Then you use 1 to divide this tiny number. It becomes approach to positive infinity. The next questions. Now we need to compute the quotient of two polynomial. So let's take a look at these questions. The highest power in the numerator and denominator is 2. So we can divide the top and bottom by x squared, or multiply by the reciprocal of x squared. And then it comes with this solving the limits of 2 plus 1 over x plus 1 over x squared. As x approaches infinity, it comes with 2. And the other method we can do is like looking at the highest power on top and bottom. If it's the same highest power, in this case 2, then actually the limits goes to infinity, the coefficient. Next question, trigonometries. So we need to use this similar techniques for combine the two special cases. So one is sine x divided by x, the other one is cosine x minus 1 over x. Look at the questions. We need to solve the secant x minus 1 divided by x as x approaches 0. So now first, we need to derive the function to the form of sine and cosine. And then we know the secant x is 1 over cosine x. Then we multiply the top and bottom by cosine x to simplify the functions. And then we can factor out 1 over cosine x and then solve the limits. We know the limits x approaches 0, the cosine x is equal to 1. Similarly for 1 over cosine x. Then we can solve the limit each individual. And the answer, because the property of cosine x minus 1 over x is 0, then it comes with 0. Thanks for watching.